Welcome back to your online CXC math tutor. In lesson 1, we looked at how to define boundaries and how to identify the region as defined by the inequation. I would strongly recommend that you review lesson 1 before you continue with this particular example. Much of what we did in lesson 1 will be applied directly in this example. Okay, linear programming is simply testing that at the CSEC level, students are able to write simple equations given a set of conditions. They are also expected to be able to represent these inequations on a graph. They are supposed to be able to shade the common region that represents the solution to all the inequations, and from that common region identify a particular x and y value which maximizes or minimizes the certain result, and of course be able to use that particular maximum solution. In this example, a company that makes pizzas must decide how many small pizzas and large pizzas to make given a set of constraints. The first condition that the company has to recognize is that its oven can hold no more than 20 pizzas. So first we need to define the number of small pizzas to be equal to x, an unknown, and the number of large pizzas to be y, another unknown. Now, because of the constraint of no more than, which is the same as less than or equal to, we can write an inequation immediately which says the total number of pizzas made must be less than or equal to 20. And of course, if the number of small pizzas is x and the number of large pizzas y, then our first equation is x plus y must be less than or equal to 20. The other constraint for the company is that it knows beforehand that the cost of the ingredients to make a small pizza is $15 and the cost of the ingredients to make a large pizza is $30. Now the company only has $450 available to buy ingredients. So it is easy to set up another equation which says $15 times the number of small pizzas plus $30 times the number of large pizzas must be less than or equal to all the money that the company has to buy ingredients. So the equation 15x plus 30y is less than or equal to 450 is merely describing the constraint of only having $450 available to spend on ingredients. So 15 plus 30y is less than or equal to 450 is our second equation. Now if you notice, we can divide that equation by 15, simplify that equation, divide through by 15, the equation becomes x plus 2y is less than or equal to 30. Okay, our next task is now to graph all these inequations on the same graph and find the common region. Notice that we have been given two additional equations, equations 1 and 2, which says that x is greater than or equal to 0 and y is greater than or equal to 0. This is merely telling us, as we outlined in lesson 1, that our region of interest is in the first quadrant, because x greater than or equal to 0 is merely saying that x should be positive, and y greater than or equal to 0 is saying that y should have a positive value also. So we are constrained to operate within the first quadrant on our graph. Graph number 3, we go ahead and graph the straight line which represents the boundary for that inequation. And as we did in lesson 1, we determine the 2 points along the x and y axes and we draw a straight line connecting those 2 points. That line is going to represent the boundary of equation number 3. And of course, the solution set, which is where x plus y is less than or equal to 20, will be found below that line. Lesson 1, like I said, outlines all of this in detail, so please review lesson 1 if you are not sure you're understanding what is happening going forward. Equation number 4 is also drawn in a similar way. We identify the 2 points on the x and y axis through which the line should be drawn, and we connect the 2 points to give the boundary of the equation x plus 2y is less than or equal to 30. Of course, the less than or equal to sign again tells us that the solution set is below the line. From these 4 equations, we can see a clear overlapping of the region that is shown shaded here. Our next task is to determine the maximum profit that the company can make, and that will depend on how many small or large pizzas the company makes. The question goes ahead to tell you that the company will make a profit of $8 on a small pizza and $20 on a large pizza. So the profit equation, as shown here, describes that particular equation. What we need to recognize now is that the maximum profit is normally found at one of the vertices of this particular quadrilateral. So at vertex A, the coordinates, which are 0 and 15, we've identified that on our common region, and vertex B, which is indicating that we're making 10 small and 10 large pizzas, and at vertex C, it's indicating that another possibility is to make 20 small and no large pizzas. So all we need to do is to plug these particular XY coordinates in the profit equation to see which will yield the largest amount of profit. So for vertex A, we plug 0 and 15 in the equation, and we see that the profit that we would obtain if we made no small but 15 large pizzas would be $300. At vertex B, if we made 10 large and 10 small pizzas, we would make a profit of $280, and at C, 20 small and no large pizzas would yield a profit of $160. Clearly, we can see that the maximum profit is obtained at vertex A, suggesting that the company should confine itself to making only large pizzas for these particular constraints.